Hello, everyone. Today I want to share a detailed analysis about the upcoming NASA ISRO SAR mission, specifically the launch of the NISAR satellite. Let's dive into the key details. The mission is NASA ISRO SAR, also known as NISAR. The main agencies involved are NASA, the NASA Jet Propulsion Laboratory, and the Indian Space Research Organization, ISRO. The vehicle being used is the GSLV Mark II, and it will be launched from the Satish Dhawan Space Center in Sriharikota. The scheduled launch time, or T0, is set for Wednesday, 30th of July, 2025, at 1700 hours Indian Standard Time. Now, I've conducted an astrological advisory on this launch, and here's what I've found. The launch window at 1700 hours Indian Standard Time on July 30, 2025, is flagged as highly unfavorable and inauspicious. Based on my analysis, I've outlined the most likely failure modes. I want to be clear, not every anomaly must occur, but these are the risks most likely to manifest in some combination. Given a $1.5 billion investment, proceeding with this launch under these conditions would be reckless. Let's go through the potential failure modes, starting with schedule slips. First, there's a 90% chance of schedule slips. Although we will proceed with the launch countdown this time, a punctual liftoff at 1700 hours Indian Standard Time remains highly unlikely. Meteorological factors, vehicle issues, and range constraints are expected to cause holds, delays, scrubs, or rescheduling. Notably, high-altitude winds, jet stream winds at upper atmospheric levels, can generate turbulence that destabilizes the rocket during critical ascent phases. These winds can lead to guidance errors, structural oscillations, or oscillatory stress, which may require reprogramming of guidance systems or cause launch delays. In extreme cases, they could necessitate holding the launch until conditions improve. Ignoring these warnings risks a watery demise or uncontrolled explosion. A similar schedule slip advisory was issued for the launch of the Blue Origin New Shepard NS-24 rocket, owned by Jeff Bezos. The launch was first put on hold due to cold launch site temperatures and subsequently scrubbed due to issues with ground systems. The evidence is in the description below. Next, there's a 90% probability of thermal excursions. Thermal excursions during ascent, MECO, and separation are expected. Although the GSLV's fuels are of exceptional quality, usually an advantage, breaching thermal thresholds can turn this strength into a significant risk. Reaching these critical temperatures could ignite the fuels, leading to thermal runaway, explosive failure, or rapid disassembly. The combination of thermal stress and potential guidance or control system failures greatly increases the likelihood of total failure. A similar thermal excursion warning was issued for the launch of SpaceX Starship 2 and shared with Elon Musk. Unfortunately, it was not considered, resulting in a catastrophic explosion of the LOX tank. Evidence is in the description below. Then we have an 80% chance of orbit deviations or deployment failures. Guidance anomalies during separation or burns could cause the satellite to drift from its planned sun-synchronous orbit. Such deviations impair instrument activation and orientation, risking premature re-entry or total loss of control. A similar orbital insertion anomaly advisory was issued for the launch of the NASA Astrobotic lunar lander, Peregrine, which flew on the ULA Launch Vulcan rocket. Despite extensive outreach, including to ULA Launch CEO Tory Bruno, who is very approachable and I like him, the advisory was not considered for various technical and business reasons, and the launch proceeded as scheduled. Consequently, the predicted anomalies occurred during orbital insertion, resulting in the complete loss of the lunar lander, Peregrine. Evidence is in the description below. Severe guidance or orbit errors will likely cause a loss of SAR imaging capabilities, up to a 90% chance, making the payload partially or entirely ineffective and leading to mission failure. These errors will impair the satellite's ability to maintain proper orientation and stability of its radar antenna, preventing high-resolution imaging of Earth's surface. As a result, the payload's imaging capabilities will be compromised, rendering high-resolution surface imaging impossible and ultimately causing mission failure. Moving on, there is an 80% chance of communication failures. System errors, software bugs, or guidance system issues during ascent could cause loss of contact with ground stations. Guidance malfunctions, anomalies, or reprogramming may prevent timely corrections or aborts, risking uncontrolled drift, re-entry, or mission failure. These guidance failures, including oscillations or stress, increase the chance of re-entry or disassembly during critical phases. All these potential failure modes highlight how critical the timing, guidance, and thermal conditions are for this launch. Now, I want to emphasize that I am ready to suggest an astrologically favorable alternative that satisfies all range, orbit, and payload requirements. Our shared goal remains a flawless NISAR mission that advances science for everyone. The decision ultimately rests with the launch team. I also want to share my proven track record of accurately predicting and influencing outcomes for all these agencies, delivering precise forecasts for their launches, delays, and failures. Whether it's the successful launches of SpaceX Starship 3 and Chandrayaan 3, or warnings about failures like NASA's Peregrine lunar lander and SpaceX Starship 2 explosion, my insights have consistently proven reliable. All of these predictions and their outcomes are documented in the links in the description below. Thank you for listening. Remember, the universe's timing is crucial, and sometimes astrology offers valuable insights. For more details, check the links in the description. And if you want to see more videos like this, don't forget to subscribe.